So in this case, I want us to consider some typical examples that we can have still on our transistors working with the decibel gain, which is one of the most important part again, where you are going to be calculating the gain, but giving that in decibels is just what you had previously in your industrial electronics N2 where you were working with the power gain. This part does not even change. The power gain in decibels can be given as 10 log P out over Pn. So the power can be calculated. This power, guys, as we do understand that power, despite being power in or power out, any power that you can just relate, because you shall be considering this as just like DC. So you're going to have voltage times current. So it depends, is it at the output or is it at the input? Power can be given from V squared over the resistance. Power can be calculated from I squared times the resistance. So this resistance is going to be considered as the impedance. So in place of this, you are going to be given as your Z. So this is going to be considered as Z, or as the resistance, which is the impedance. So these formulas can be used to calculate power. What I'm simply trying to say is if it is power in, then this is P in is equal to I in, then this will be Z in. If it is P out, it's going to be the same thing. P out, this will be I out, this will be Z out. So we just need to consider which part are you referring to in terms of the power, but that is 10 log P out over P in, measured in what? In decibels. The other part that you need is the voltage gain, again in decibels, which is our AV voltage gain. That's 20 log V out over V in. So voltage again can be taken. Is it from the power? Sometimes you are given voltage, which can be calculated from current times resistance, but this resistance is what? Your impedance. So it's going to depend. Is it at the output? So it's going to be V out is equal to I out, Z out. Is it at the input? Then this will be in, then this will be in, this will be in also. So it depends, but voltage can be taken from the current times resistance, which is current times impedance, or you can take your voltage. Maybe you are given power and current. You can take it from there. You make it power the subject. You make V the subject. You are given from this one. You can make V the subject as long as there's a voltage. The same thing with the current gain, which is 20 log I out over I in. The current also can be calculated from the voltage, from the power, whatever connection that you can use. So as you can see, it's only the power gain which has got a 10. The others, voltage and current, they use 20 of what is their voltage, V out over V in, current, I out over I in. Same with power, but only power is going to be using a 10. That is the only difference on this formula. So let us quickly check our questions and see how they might be given. We are given in this example that an amplifier, here's the following specifications. The input power, so there we are given the input power, the output power, the input current, and the input voltage, and the output impedance. So take note, this is our Z out, the output. So from these values that we are given, use that information above to calculate or to determine, number one, the current gain, but it's supposed to be in what? In decibels. So the current gain, how can we calculate the current gain? We saw that this can be calculated. So number one, from our formulas, we saw that our current gain is given by 20 log I out over I in. That is output current over the input current. So the question is, are we having all these? That's the question. Are we having output current, the input current? So from our information, the input current is there. This one we have, but the output current we do not have. So thus, we are forced to calculate this output current from where? That is where we have to figure out. From the output values that we are given, what is it that we have at the output? There is power and there is impedance at the output. We have got power at the output. We also have the impedance, which is our resistance at the output. what we need is to calculate the output current. Where there's power and impedance, which formula are we going to use? Remember that this power can be connected power in terms of the impedance, and the current we saw that is I squared times the resistance, which is our impedance. So at the output, this is just going to be P out, I out like that, like I stated before. You just have to consider which formula that you work with. So we need current and impedance. This is the best formula that we can have. And from there, we can make this current the subject. So if you're using this textbook, I think is supposed to be hands-on, they just made a simpler mistake in the calculations. I is raised to the power of 2. So in order for you to make the subject, you divide by this Z out, you divide by Z out both sides. So this can cancel, meaning to say I out raised to the power of 2, there's a power there, is equal to P out over I over Z out. So there they made a mistake of using this formula as it is. No, we are supposed to remove these 2. And how do you remove 2? You introduce the square root. So it's supposed to be the square root both sides. So that's I out is going to be the square root of P out over Z out. So if you are using this textbook of the hands-on, I want you to just make corrections on that part on the calculation of this current. So that's I out is going to be the square root of P out, output power. We have got our output power. Remember, that's 1,000. So it's going to be 1,000 over the output impedance. This is Z out. That is our output impedance. There we have got 20. So there they just used this 1,020 like that and obtained 50. No, it's supposed to be under the square root of 50, which is going to give us something like 7,071 amps as our output current. So with this output current, we are going to use it now to calculate our gain, which is 20 log of the output current, which is the one that we obtain. That's 7,071 over the input current, which we are already given from the information. The input current IN is given as 200 amperes. So that's 200 in that case. So this was going to give us the current gain, and that was going to give us negative 29,031 in what? In decibels. The log part, once you use this log, you know that you are dealing with what? The decibel. All right. So that was for the current gain. We move on to the second question. This time they need the voltage gain. All right. So for the voltage gain, we also have the 20 log. So it's going to be 20 log V out over Vn. So the question is, are we having these, the voltage at the output? If you had to check here, we do not have. We've got the input voltage. At the output, this one, we do not have. We are given at the input. So at the output, how are you going to calculate the voltage at the output? Remember, we have calculated this current, so you can use the current. It's up to you, because we also have the impedance there at the output. So it was up to you which formula are you going to choose. So to calculate, let us just write here to calculate V out. So we can have our V out, since we have got current and impedance. Remember I said voltage, that's current times what? Impedance is going to be I out times Z out, which is the output current. Sorry, this is the one that we got here, 7,071 times the output impedance. Our output impedance is what? Is 20. So the product of these two was going to give us the output voltage, which is 141,42 volts. So this is how you could have calculated your output voltage. But is it the only way? No. Remember, we have the output power and the output impedance. Previously, we're given this. We calculated this. So meaning to say we can work from there. So I'm just going to remove this part so that You can utilize this space here. So remember, we had the output power and the output impedance. Remember that. So from our formulas, which formula connects power, voltage, and impedance? So from this case, we are going to notice that the formula is going to be given from this part. P is V squared over Z. So using this formula, we are still calculating the voltage. Using the formula, power is equal to V squared over Z. This is at the output. So it's going to be P out. This will be V out. This will be I out. This will be Z out, I mean. So you need the value of the voltage. So let's cross multiply these two. Is going to be V out squared is equal to the product of these two, which is P out times Z out in that case. But what we need is V out, not the square of V out. So we're going to remove the square by introducing the square root both sides. So that was going to give us V out, which is the square root of P out times Z out. Okay, so let's see with what we have, because we have these values P out and Z out. Remember, our output power is 1,000 and our Z out is what? Is 20. So that's 1,000 times 20 under the square root. So it was going to be the square root of 1,000 times 20 like that, which was going to give us the same answer of 141,42, but this was going to be 421. This one was going to be 42 according to your calculations, all right? So this, because we are using the current, which is a rounded off value, this one. So that's why our value is not exact. But as you can see, guys, there's nothing that is different there, just the one there. So I'm just going to use that one with a 1, which is, this one is going to be the exact value, because here we are not using any rounded off figure. We are using exactly the values that were given from our information. So that was going to give us the voltage gain. So you need now to calculate this from the formulas. So it's going to be 20 log V out over V in. So like I said, I'm just going to use the exact one, this one, which is 141.421 volts. So if you are using this one, I'm not saying it's a problem. No, you can use it like that. It's not even a problem. As you can see, guys, it's just a difference of that smaller one. Does not affect that much our answer. Then the input voltage is 200 volts. We are given here, which is 200 volts. So whatever that you're going to have is going to be divided to 200. That was going to give us the voltage gain at the end, and that was going to give us minus 3,010 in what? In decibels, which is just simply minus 3.01. So this is what we have, just like that. So we need to calculate from those formulas, which formula are you going to use to obtain the value that is missing there. All right, another part, it was the power gain. So for the power gain, we already have everything. The input power and the output power is given. So for the power gain, this was just going to be a direct formula in that case. Remember, our power gain from the formula, we said the power gain can be given from 10 log P out over Pn. Okay, so this is measured in what? In decibels. So meaning to say our power gain, that's going to be 10 log output power, which we are given the output power is 1,000 watts. So this is 1,000 over the input, which is 3,500 in that case. So this was going to give us the power gain of negative 5,441 in what? In decibels. Just like that. So this is what you actually need to work on, revise your formulas to see which formula is the best to apply in your calculations. All right. There's also another question which is to be considered. An amplifier circuit has got the following values. We are also given on this question here, we have got the output power, which is 600 watts. The input power is also given, the input voltage, and we've got the output impedance in this case, which is Z out. So calculate number one, the power gain in decibels. So this one is also direct. We've got power in and power out. So meaning to say we can calculate our power gain, which is 10 log P out over Pn. So this is just to be substituted. So it's going to be 10 log P out, which is 600 watts. So we've got 600 over Pn. That is 600 milliwatts. So that's 600 times 10 to the exponent of -3. Remember the milliwatts. So your answer is going to be in what? In decibels, as I said before. That was going to give us 30 decibels as our power gain. Number 2, it was to calculate the voltage gain. So that's number 2, our voltage gain in that case. So voltage gain, we saw that's going to be 20 log V out over Vn. So it's just a matter of substituting. But are we having these values? Vn is given, but we do not have V out. So we are back to that other part that we used before of calculating from what? The output power and the output impedance. Remember, we formulated these guys from the output power. That's from the output power. Power is equal to V squared over I. So it's going to be output like that. And I made this the subject. If you still remember, it ended up giving us the square root of P out, I out like this. So meaning to say we can calculate our V out, which is the square root of the output power. Your output power 600 and your impedance output, which is 30. So that's 600 times 30 in that case. All right, so this one, guys, it's just a repetition. I talked about this formula. So meaning to say that was going to give us 134.164 volts. With this, we can calculate our voltage gain. So this is what they're just simply going to be testing you. They want you to see, are you going to be able to be calculating all these values from other formulas that you are not given from your normal formulas. So the input voltage, remember we have our input voltage was 20. So this is going to be 20. So this was going to give us the voltage gain, and that was going to be 16.532 in what? In decibels. We need some of the values from the information that you'll be given that is missing so that you calculate that. And from there, you can calculate any other part that is being asked there. All right, let's check another question. Again, on these calculations, they need us to determine or to have the current gain. Okay, so what is going to be the current gain? So let us just have our calculations here. So remember also on our formulas that the current gain is given from the formula 20 log I out over I in, output current over the input current. So do we have these? From these calculations that we are having, none is given. None of these. Output current is not there. The input current is not there. So you can calculate the output current. Remember, we have got the output power and we have got the output impedance, this one, or you can use from the voltage. Remember, here we calculated the output voltage. So we can also use that. Guys, we can use any part that we want. We also have the output voltage, remember, which is 134.164. So in this case, it was up to you. Which formula are you going to use to calculate I out? All right, so let's calculate the output current in that case, all right? So from the power and voltage, what are we going to have? From power and voltage, power is voltage times current, meaning to say if you want current, it's power over voltage, meaning to say this will be output, this will be output, and this will be output. So meaning to say the output current can be calculated from P out. And what is our output power? P out, that is 600. So we've got 600 over V out, which is this one that we calculated, 134.164. So this will give us the output current, which was 4.472 amps. We calculated this from what? The power voltage. But also remember you have the output power here and what? And its output impedance. So you could have calculated this from what? Power and what? Impedance. How do you calculate this? Remember that power. So this is another way that we could have calculated this output current. Remember, power is equal to I squared times the resistance, where resistance is our impedance. So you can make I the subject, that is divide by Z in that case. So meaning to say I squared, it's P over Z. Introduce the square root. So that means our output current is equal to the square root of the output power over the output impedance. I talked about this formula, if you still remember. So let's substitute and see what we were going to have at the end. All right, so meaning to say here, our output power is going to be the square root, the output current was going to be the square root of the output power, which is 600 over the output impedance, which is 30. So that is the square root of 20. Actually, this one is going to give us the square root of 20, which is 4,472 amps. So as we can see, we are obtaining the same value of current. Either way, I don't know which way were you going to take or make in your calculations. We are going to obtain our output current as 4,472 amps. All right. So let's see, how can we calculate the input? Because as we can see on these calculations, we do not have also the input power with the input current here. So we have to consider the input, what we have at the input. What is it that we have at the input? At the input, there is input power, there is input voltage. So you can take advantage of that at the input. So in this case, we're going to calculate input power, input current, calculate the input current. So at the input, there is power, there is voltage. Remember, power is equal to voltage times current. So meaning to say, to calculate current, current is equal to what? Power over voltage. So meaning to say, if this is the input current, this will be the input power, the input voltage. So let's substitute our values. The input power, that is 600 milliamps, 600 times 10 to the exponent of -3, over the input voltage, which is 20. That was going to give us the input current, which was approximately 0,03 amps as our input current. So we have our values, guys. The input current is there. Output current, we calculated. This can give us now the gain, which is our current gain. So at the end, we are going to calculate our current gain. So therefore, our current gain was going to be 20 log of the output current. What is our output current? 4,472 divided to the input, and our input current, that's 0,03. So with this, you are going to obtain your gain. You calculated all these values. All right, so therefore, our current gain in decibels in that case was going to give us 43,468 in what? In decibels. So that is what you must expect in your typical questions as you're also to revise your question papers. You see they are going to be having questions of this nature also. So just make sure you do understand the formulas of the decibel gain and the relationship that is between these in terms of the voltage, power, current from our normal calculations of power, voltage, whatever that you have. The impedance there, whenever you're talking of the impedance, just put this as the resistance. That is the resistance. You are simply talking of what? The same way that you used as resistance. So if you understand that power is V squared over R, in place of R now, you're just writing Z. If you understand that power is equal to I squared times R, in place of this R, you are going to put a Z. So just go through these questions, do revise many questions as much as you can. Also on the voltage, remember voltage is current times resistance. But in place of resistance, you're going to have a Z. So the Z, the impedance, is simply representing the normal resistance that you are given, the normal resistance. So this is how you're going to calculate your values in decibels. Till we meet again.